Hey guys, this is Harold L.R. Watkins back with another video demonstration. This is AutoSec Local AI, a private artificial intelligence assistant that are designed for automotive diagnostics, vehicle testing, and cybersecurity analysis. It is written in Python and runs a language model directly on my computer. This allows the application to assist with sensitive automotive information without requiring a cloud service. And as you can see, this is my local model, which I load here. I already loaded it. This is my assistant mode, which allows you to select UDS diagnostic, analysis, cybersecurity test planner, or plain language coach. This is my generation settings. You can set temperature from all the way to 0.3 all the way down to 0. Maximum response tokens, you can go up or go down with your response tokens. You can clear conversation, export transcripts. You can also select if you want to use CPU baseline or GPU accelerated. Um, so I'm gonna reload the model and let's begin. So the first feature is trusted UDS decoding. UDS is a communication standard used to diagnose and program vehicle control modules. Exact diagnostic values should not be guessed by artificial intelligence. So this application uses reviewed Python logic for those facts. So here I will click on decode 727 7F2735. I hit analyze and the message is a negative response to the security access service. The final value means invalid key. Um, the application explains the likely cause and recommends requesting a fresh seed, confirming the correct security level, and checking the key calculation. This answer comes from deterministic logic, so the language model cannot rename the service or invent the meaning. So here we're going to click on draft test cases and hit analyze. The second feature creates structured security access test cases. These include normal operation, invalid keys, incorrect message order, timing, and repeated attempts. This gives an engineer a useful starting point while still requiring final review against the authorized test plan and the vehicle specification. So you can see this here. I'm now going to clear this input. Start fresh. Um, all right. Um, this question uh, demonstrates the local language model. The the model handles the broader explanation, while the application supplies reviewed automotive information and checks the response for unsupported protocol claims. This combined approach provides the flexibility of artificial intelligence with the accuracy controls needed for automotive cybersecurity. Um, let's go here. Give me a moment. So we're gonna, all right, first we have to run the model, let that run, and we are going to click analyze. The interface also includes 3 assistant modes: conversation, memory, quick prompts, stop control, transcript export, and clear status messages. These features allow a first-time user to understand what the application is doing and whether an answer came from validated logic or the local model. And just let me look at something real quick. Okay, got it. All right. So moving to showing the performance lab accelerator, which we have here. Um, so I added a control performance lab. I tested the same Llama 3.2 3 billion parameter model with the same prompt and settings on both the processor and the graphics card. The CPU response took about 19.915 seconds and produced 7.82 tokens per second. With with uh, NVIDIA CUDA acceleration, the response took 6.337 seconds and produced 40.367 tokens per second. Um, so I can change this over to CPU base. Um, it does take a little bit longer. I'm going to clear this, just have a fresh start. Let's do this. So, all right, so we have CPU. I'm going to load this model. Um, and we can run tokens. So this is going to take a little while. Let's let it run. All right, there you go. So, so this, and then I'm going to compare it. You see how long it took, and then we're going to change it over to GPU accelerated. So I'm going to reload this, and then I'm going to run this, and you're going to see the difference. This is a little bit more faster. There you go. Boom. So that reduced the total response time by about 68% and increased writing speed by about 416%. The screen confirms that GPU, although was active during the tune run, um, this makes the assistant fast enough for practical daily use. And we're gonna move to let me show you. Let me show you this. So we can export. So I'm not gonna put it there. I'm gonna put it. This is go here first. Go here, advance. I'm gonna put it here, and then I'm gonna grab it from my folder. Uh, and, hold on. All right, so the looking for it in my folder real quick. Okay, got it. All right, that's loading up. There we go. All right, so stretch this out some. Boom. Doesn't need all that space. That doesn't need a bunch of space. And you can see the difference in CPU. There you go. Versus GPU. Make that easier to see. Perfect. All right. So now you can see it. And just open that up. Okay. So you see um this is the CPU being used without the GPU, and this is the GPU being used. Then you see the difference token seconds, output, tokens per second. The higher the token is, uh, the faster it's uh, responding. Okay, so let's go to the PowerShell. Uh, and we can show the complete test. Let me just grab it from here. And you can see here, I'm using NVIDIA, and we got to run the complete test from here. I'm actually gonna clear this, and I'm gonna run. Oh, all right, give me a moment. Let me grab the complete test. Give me a moment while I pull up. I'm gonna type this in. Got it right here. So, yeah, let me start fresh. So, uh, this is it. Yep, this is it. Run the PowerShell here, and then grab this. Perfect. All right. So the application includes 51 automated tests covering UDS, decoding, trusted knowledge, accuracy, controls, prompt construction, CPU and GPU profiles, performance calculations, and CSV evidence. All 51 tests passed successfully. AutoSec Local AI demonstrates Python programming, local artificial intelligence, automotive cybersecurity knowledge, measurable performance, tuning, error handling, and a practical user experience. Um, the result is a private assistant that can support diagnostic analysis without replacing engineering judgment. Thank you for watching.